Okay, so we're back and we just finished setting up our our inbound call routing from the PSTN. Not only our voice port, currently our single inbound dial peer. We'll look at a time when we might want to set up multiple dial peers in a little while. And our voice translation rule that takes our 10-digit called number and truncates it down to 4 digits, which serves both SIP and skinny phones. So now we want to take a look at our outbound dial plan, or really we want to create and configure our outbound dial plan. So to begin with, I'm going to say, obviously, global config T mode. And I'm going to say dial-peer voice, let's start with 10 for POTS. And we're going to create a dial peer for POTS. And this time we're going to create an outbound dial peer. So we remember that inbound dial peers, and I'm just going over this and hammering this into your head because of all of the things that are the absolute most important and the things that I see even my CCIE voice students in class failing to remember time and again, is how to make sure that the inbound and outbound dial peers are properly matched, believe it or not. And so that being one of the most crucial things of iOS voice gateways, I almost but guarantee you're going to see questions related to it on any sort of exam that you would go sit for. So remember that our inbound is matched from things like incoming called number. Okay? That's the first option. The next option is, is answer address. Now, incoming called number matches DNIS or called. Answer address, even though it seems like it might match a called, it matches calling. In fact, the easy thing to remember is on the inbound, everything matches calling except for incoming called, and the name is right there in the command. So answer address matches calling, destination pattern on the inbound matches calling. And remember, there's no way to distinguish a dial peer and say you are an inbound dial peer or you are an outbound dial peer. We simply use human logic in configuring and provisioning our dial plan, which is really, our dial plan is just a summary of all the dial peers in our router and the various digits associated. But when the when the iOS router sees a call come in, it will use all available dial peers to try to match what is the best match and therefore choose dynamically an inbound dial peer. Now we're dealing with outbound dial peer. So I'm going to use destination pattern. And you might say, well, if I'm using destination pattern, how will the system distinguish between it being used for inbound matching calling or outbound matching called? Well, the answer is it just depends on what the inbound calling digits are. If I created something that was very specific and it was 206 501 5111. That was the calling number that kept calling in. Then destination pattern would match that as a calling number. But remember, there is a priority to the match. So if we have an incoming called number command that at least matches the called number, and incoming called number dot, parenthetically, matches everything, every inbound called number, then it will always trump an answer address command or a destination pattern command. So while a particular pattern could match an inbound calling number based on destination pattern, it will not, provided that we have an incoming called number command which trumps it. Okay, so I want to make sure that that's clear. So now we're setting up our outbound dial peer, and we're going to set up our first dial peer to emergency services. So let's say 911, and I like to use, I've always been in the habit of using the $sign at the end of my patterns. You don't necessarily have to. In fact, for the sake of this particular class, I'll just leave them off for right now. but I do typically put them on iOS, as we just saw when we created an ePhone DN. Actually, if I do show dial-peer voice sum, we saw that skinny-based phones put the $ on, SIP-based phones did not. So different times that these particular modes of CME or signaling protocols for CME were set up, they chose to do it differently each time. What can I say? Okay, remember the $ just matches the end of a string. So I've got my destination pattern 911. I need to say the port that I'm going to send it out of. Now, we call it voice port everywhere else. Here we simply call it port. And if we'll recall, it is 0/0/0:23 is the D channel where we're going to send the digits. And then the D channel is responsible for provisioning or choosing an available, really negotiating an available B channel. Okay? We don't send to a particular B channel. We let the D channel do the work of provisioning which B channel is best, really which B channel is available. And there is an order that we choose B channels. We either choose them something called ascending or descending. So if we're choosing them ascending, then we're choosing them ascending numerically. So beginning at 1 and going up to 23 or 22, depending on how you're counting. If we're choosing them descending, then we start at 23 and go down to 1. So this is the work of the D channel. That is a configurable value under the serial interface, the D channel interface, but we just send the calls to the D channel. Now, do show run pipe to begin with dial-peer. I've got my inbound dial peer 1, my first outbound dial peer 10, which is the pattern 911. Something that's important to discuss now is the fact, or really is something called digit manipulation. Now, we've already begun to look at digit manipulation from the perspective of a voice translation rule, which is a very powerful digit manipulation window or mechanism. The idea of digit manipulation is just that, manipulating the digits, affecting them or effecting them, whichever would be more proper, in some way. Okay? So we want to change digits. Now, why would we want to change 911? It already is in the proper format. Well, maybe we don't want to, but what we need to know is that all POTS dial peers, not VoIP dial peers, but POTS dial peers do digit manipulation by default. So let's actually just go ahead and back up and take a look at the dial peer that we just created. Now you might say, you just did that, Mark. You just did a show run pipe to begin with dial peer. No, we just see the non-default configuration. As soon as I created dial-peer voice 10 POTS, a lot of default information was set up. What is that information, you might ask? I'm glad you asked. Let's take a look at it. Let's do show dial-peer voice 10. And I see I'm going to hit space and space again, and I see that I have almost 3 pages and I'm just copying this to my buffer or clipboard. And then I'm going to bring up a text edit window. And if I go down to a very small font, you can see that I have everything all of a sudden on one page. But if I go up to an actual readable font, then you can see that you can see my scroll bar, I've got, of this size font, I've got about 2 pages of information. That's all applied to voice encapsulation peer 10 or dial peer tag 10. Okay, what peer type is it? It's a voice. Okay, system peer default. No, it is not the default system peer or dial peer 0 that we talked about. Destination pattern 911. Okay, we set that. There's all sorts of information on here. Caller ID restriction. No, we're not restricting any caller ID. Is there an answer address command? Nope, it's not there. Is there a preference? There is a default preference, which is 0, the most preferred. Is there a carrier identification number tagged? Nope. We simply have nothing. Okay. Is there, what's the administration status? It's up. What's the operational status? It's up. There's actually 3 statuses. With an IP, whoops. If I go back to my router, if I do a show IP interface brief, you're used to seeing the status of an interface being up and protocol being up. We typically refer to that as up and up, or maybe up and down, or possibly down, down, or administratively down. Those are IP interfaces. If I do show dial peer, dial dash peer, voice summary, I see that I have an admin. So look at that column, the administrative status. Okay, that is, do I have the shutdown command on a dial peer? I can shut a dial peer, and then it will be administratively down. Is it operational? Yes, the operational status is up. So these are my sort of similar up and up. But then I actually have a third status, which is my outbound status. In this case, I see that I only have one outbound status being up. My dial peer 1 is up and up administratively and operationally, but outbound status is down. Why? Because I don't have a port associated. I don't have a port associated because it's my inbound dial peer. So it's no problem that the outbound status is up. I don't want to use it as an outbound dial peer. I only want to use it as an inbound dial peer. That's why I don't have a destination pattern either. So it's fine as long as it's operational and administratively up. It's fine that dial peer 1 is not up in an outbound status. So those are my 3 states: administratively up, operationally up, and then outbound. In this particular case, we're back to the 911. Peer 10 is also up. Okay, I've got a lot of information here. Do I have class of restriction? We took a look at that in CCNA voice. We'll look at it more here in CVOICE a little bit later. But do I have class of restriction? There is no incoming core list, and therefore I have maximum capabilities. Okay. Do I have translation profiles, incoming or outgoing, associated with this dial peer? No. I have them associated with a port, but not this dial peer. Call blocking. Translation profile. There's actually something called voice translation profile or voice translation rules. And then there's also something called translation rules. But we won't really talk about the latter, because they are older and much less, shall we say, able. They have a lot less capabilities. So we use voice translation rules these days, but that's what that is. I'm not going to go through everything, but what I do want to look at is this right here. We were talking about digit manipulation, and this is something that is enabled by default. Digit strip enabled. Okay? Digit strip enabled. So, what is digit strip enabled? What digit strip enabled means is that, and let me bring up my, that's okay, show run pipe 2, begin with dial peer. Digit strip states this rule. And again, this is only for POTS type dial peers. If any digit in the destination pattern is explicitly defined, beginning from left to right, and only while there are contiguous explicitly defined digits. So if I have, well, I'll come back to that. But if I have any explicitly configured digit, that is to say it is not a wildcard digit, then those digits will, by default, be stripped. That's what digit strip enabled means. So when this call goes out to the PSTN, if I were to pick up a phone and dial 911, then it would match this outbound called number. It would actually match this as the called number and therefore turn the dial peer into a match for an outbound port and send that call out this port. Now it would send the call out the port, That does not mean it would send the digits out the port. It simply means it will send a call setup out that port. The digits would be stripped off, so nothing would be sent out the actual port. Let me demonstrate. Debug, I've got Q931 on. I'm going to actually take undebug voice translation off. So now I've only got Q931 debug turned on. And let's just go ahead and pull up our phone and say dial 911. Hear the reorder tone. Okay, I've gone and hung up the phone. So why? We transmitted a setup. We have our calling party number is 1001, and our called party number is blank. It is not there. We have absolutely no information. Oh, you know what? And I also tried to set up on channel 6, and actually the reason that this particular call got denied was because this requested circuit or channel is not available. I actually have only 3 BRI channels set up on my PSTN. I'll change that at a break, but until I change that, what I'm going to go ahead and do is, just so that we can move on with this particular module and demonstration, is I'm going to do show run interface serial 000:23, which is the ISDN, the ISDN interface. And I'm going to jump into that interface, and I'm going to say, we just talked about how I can choose either ascending or descending. Currently, I'm choosing descending, which, because I don't see any configuration here regarding descending, must be the default. So I'm going to say ISDN B channel number order, and do I want to start from B1, the bearer 1 channel, or descending from 23 or 32, depending on if this is a T1 or E1 PRI. The D channel doesn't really know or care. It's the, well, I suppose in a sense it would know, but anyway, this is just saying depending on if it's a T1 or E1. But at any rate, ISDN B channel, I'm going to say ascending. So instead of starting from channel 6, which was, I told it the PRI time slots were 1 through 6 earlier under my controller, I'm now going to say start from channel 1. So it will go up to 3, and then it would try to go to 4, and I don't have 4 provision, but it will always try at 1. Okay. So let's do this call again. Now this time we didn't hear reorder. I said channel 1 was the channel, and then after I had received call proceeding, it's trying to find the particular route. I never got call alerting. I didn't receive a alerting, so it never tried to ring the phone. I simply received a disconnect under normal causes. Why? Because the called party number basically does not exist, so it couldn't route the call. It wasn't that the number was unallocated or unassigned. It was the fact that there was no number. It's kind of like, don't try to bend the spoon. That's impossible. Only realize the truth, that there is no spoon. So anyhow, there was no called number. So that's because of our friend digit strip. So what are we going to do about it? Well, we're going to go back into that dial peer, and we're going to say one of a few things. We could either say no digit strip. That is to turn that functionality off. Oops. So now we turned off the functionality of digit strip. That's fine. Let's leave that there. And let's say, let's go ahead and try our call again. Oops, doesn't look like I clicked it. And now we can hear that the phone is ringing. If I update my PSTN screen, you should be able to see, once it refreshes, there we go, that the call's coming in. and we sent the 911. Okay, I'm going to go ahead and hang up. So we did actually send the call out to 911. So that was one way to handle it. Let's go back into config T. And so that was one way to handle the existing default behavior of digit strip. Now let's create another dial peer 11 for POTS. And let's say this destination pattern is going to be 911. Because what if users dial a 9 for outside dial tone and then 911? We want that to be supported as well. And we want that to go at the proper port. The only problem is, if we were to do no digit strip on this dial peer, it's going to send 911 out. It's going to send all the digits. We don't want that. So what we have to use is some sort of different form of digit manipulation. And what we're going to do is the forward digits command. So forward digits is going to say the number of digits of right justified, or from the most significant digit, that is from the right over towards the left, that should be forwarded on to the PSTN. We can do all, we can do extra, or we can do a certain number from the right. And we know that 3 digits we want to be sent on. So if I do forward digits 3, then I look at my dial peers, I see that I'm doing things 2 different ways. I could have used forward digit 3 here as well. I just wanted to show the no digit strip a different way to do it. So now, if we dial 911, oops. Oh. Is that screen not updated? It's not updated there we go. I wondered if my user ID timed out. So I'm going to dial 911. And we see that the call went out. Now, how do we know it used the right dial peer? Well, let's go ahead and answer that call. You may have heard some feedback while I quickly pressed mute. So we're now connected on that particular call. And now I want to do a show command such as do show, let's see, how about do show call active voice? Now this is going to give us a lot of information, okay? We can obviously see I'm paging, I'm hitting space and paging through. If I go all the way down to the bottom, I can see I've got 2 telephony call legs, and they are not SIP, H323, call agent controlled, which is MGCP, or skinny, or multicast for that matter. So that means they must be POTS. I'm coming in POTS, which is a skinny-based phone, an EFXS, and I'm leaving through POTS. But which dial peers are they? They were actually up there. I'm going to show pipe to include peer ID. And I can actually see that they're inbound through peer ID 20001 and outbound through peer 11. So it shows peer 11 as its outbound dial peer, which makes sense because I dialed 911 and that's the only match that I have. Do show voice call sum is another way to see I've got a call coming in on 50/0/1.1, so the first media channel of my first port, G711 MULA. It's my EFXS port. It's in connect state, and it's going out my first B channel, 711 MULA. Now, it's not going out over the actual B channel 711 MULA. It's just being transmitted between this phone and here, 711 MULA. Okay? I could also do show call active voice compact. And this is a nice, easy way. I can see that now this doesn't show me shows me the peer address, but it doesn't really show me the dial peer number. Okay, so it's got my originator. Actually, this is kind of backwards, but it's got Peer 1001 is the calling party, and 9911 was the dial digits. So there's a lot of different show commands that I can use to look at calls that are running. Okay, so I've got that call nailed up. I want to go ahead and discontinue that call. And now I'm going to go ahead and I'm going to create the rest of my dial peers. And I'll be a little bit faster on the rest of them. So I'm now going to create dial peer voice, let's say 20 pots. And I'm going to say destination pattern is going to be 9. And I'm going to use, this is a little bit more standard to North American numbering plan. You don't necessarily have to know it. I don't really believe for the exam, but it is fairly straightforward. 9 is just the outside dial tone, so PSTN access code. The rest of the digits, if it is a local number, it needs to be, in my dial plan, 10 digits, so acting like it's a big city. So, and the first digit of a city code cannot be 0 or 1. Okay, that's just a rule. So 2 through 9 is the second digit, could be anything 2, 3, 4, 5, 6, 7, 8, or 9. Remember, that's what the left and right square brackets indicate. Okay, so 2 through 9, ... And then I'm just going to have, I'm going to go ahead and do it proper North American numbering plan, which is that what we would call a prefix also can only be 2 through 9, ... and then ... So a total of 10 digits where the first digit and the fourth digit can only be 2 through 9. If you at least remember that the first digit can only be 2 through 9, you'll be doing fine if you're not from within the US. Okay, so that's my destination pattern. Now, my port is the same as everything else. Do I need to have digit, I already have digit strip. That's enabled by default. We've talked about that. But do I need to have a forward digits? I know that the PSTN wants to see 10 digits. This, second and third, fourth digit, fifth and sixth, 7, 8, 9, 10 digits. I know they want to see 10. But do I need a forward digits 10? I don't. And here's the reason. Remember I said that digit strip only strips from the left to right explicitly matched digits. That 9 is explicit, but I only used it as an access code for the phone system itself. I would not transmit it out to the PSTN. Just like if you were dialing 0 for secondary access code, secondary dial tone, you wouldn't transmit that out to the PSTN. Now, you may transmit a 0 for national dialing from anywhere else in the outside the US, but the initial 0 for secondary dial tone, you would not. So the 2 through 9, this is not an explicit digit. This is a wild card. It can be 2 or 3 or 4, etc. So I actually don't need any forward digit command here. So if I just look at my command, my dial peer again, I did not have the forward digit command. Okay, I am going to create another dial peer, being 30, and I'm going to say destination pattern is going to be 9-1, and then the same rest of the digits. 1 indicates a national or long distance call. With this, I am going to need forward digits because 9 is explicit. Well, stripping that is fine, but I don't want to strip the 1. Because of that, I'm going to say forward digits 11. So first let me put the port in there. Not that I must, but forward digits, then 11. Okay, and then I'll create another dial peer. We'll call it 40, and this will be destination pattern, and it will be 9 for secondary dial tone, and then from within the US, 011. Now that's my international pattern, or my international PSTN access code. It's only relevant to North America, though. I do want to send it out to the carrier to indicate an international call, but they will, of course, strip it before they send the call on. They'll only route with the E164 number. So what comes next is the country code, and then the city code, and then the rest of the subscriber digits. The problem is the PSTN itself, the E164 plan, is variable length. So if I'm going within a country, I, depending on the country, may or may not have variable length numbers within my country. Now, the US has a numbering plan called the NANP, North America Numbering Plan. It does not allow for variable length calls. Some other countries do have variable length numbers. Now, it's first I should state that different countries are variable length from each other. So as I mentioned, let's say for the UK, I've got a 2-digit city code, and then I've got 8 additional digits. Within Netherlands, I have a 2-digit city code and then 7 digits. So there in the UK, aside from the country code, I have 10 digits. But in the Netherlands, I have 9 digits. Now they always prefix those with a 0, so that changes 10 and 9 to 11 and 10 respectively. But the bottom line is that from country to country, the length of digits differs. Sometimes even within a country, the length of digit differs. Okay? We'll talk more about that later when we get to CIPT2. But for right now, it's important to know that different countries' digit lengths differ. Variable length, and because of that, we don't know how many digits will follow. Because we don't, we simply issue the capital T for initiate interdigit timeout. So we're waiting to see what are the rest of the digits. Now, the phone user could be a standard phone user where they dial 9-011, then their country code, city code, rest of the digits, and wait. Or they might be a power user and they know to go ahead and dial, on most phone systems, a hash or pound. We don't need to enter that hash or pound in iOS. It's there by default. It's called a terminating character. We can change it, but it's hash by default. So that single destination pattern will take care of it. Now if I do, let's add the port, and then let's show all the dial peers. So if I have my 9011, we were just talking about digit manipulation, digit strip, forward digits, etc. How many digits do I need to forward? Well, I know I need to forward these 3, but how many afterward? And again, if I have a variable length plan, I cannot choose how many digits, or I can't possibly know how many digits I need to forward. It could be different depending on the instance of each call that goes through the system or through this dial peer. So what am I to do? Well, I could say no digit strip, but that's going to send the 9 as well, and I certainly don't want that. I could use a voice translation rule. That is one way to do it. It's a bit of overkill, but I can use that. There's also a command called prefix. Okay, I guess there's other unambiguous, preference and preemption. Okay, so there's a command called prefix. So what prefix does is I go ahead and know, I was going to say assume, but I don't assume, show dial peer voice 40 would tell me that digit strip will strip all 4 of these digits. What remains is the country code, 1, 2, or 3 digit country code, city code, rest of the subscriber digits, but that's what's going to be forwarded onto the PSTN. The PSTN requires the 011, so after the 9011 was stripped, I'm going to prefix 011 back onto it. So now I've got the prefix command that's going to prefix 011 on after 9011 was stripped off. So let's go ahead, now that we have basically a full dial peer or full outbound PSTN dial peer setup, and I'm just going to copy this out because we're going to paste it into our branch 1 router as well. Let me just put it into Notepad here, because we'll be using it here in a moment. But switch back to the router. I'm going to clear off my screen and scroll back, and we're going to go ahead and test outbound calls. We've already tested 911 and 9911. So let's test a local call. 9-206-501-5111. How do I know what that number is? Because after I update the screen, PSTN phone has a habit of not updating its screen, mainly because it's a 7960 phone. It's a little bit older and the web server is a lot slower. So is the processor. But I know that that is a number out on the PSTN. And in terms of how you would know if you rent rack time from us, we actually have a PSTN configuration. We not only provide you with the sample configuration, but even if you don't want to look through that, we provide you with a how to dial guide. So how to pick up the PSTN phone and dial into any of the sites, and then also how to dial from any of the sites to the PSTN. So I know that this isn't doing anything right now because I'm not dialing in. I know that that is a local call that should ring to the PSTN. So I'm going to go ahead and hit dial. And I can hear it ringing. Behind me, I can see that I dialed 9. Well, I can see that on the phone, but I can see that only 206-501-5111 were sent out. And if I go take a look at my original pattern, I see that I did I did nothing related to digit manipulation because digit stripped that 9 by default automatically, and that's all I needed stripped. And I'm going to go ahead and hang up the call. The fact that it was ringing is good enough for me. I don't really need to connect every call. It's always good to connect a first few calls to a given location, but once you've done that, probably, unless anything else changes on the particular parameters related to where you're going, session target for for voice over IP, or port for POTS, unless you're going out a different port, then the first connect should probably be okay to make sure that I actually have media. And actually, that just reminded me. If I do a show controller, T1000, I still have slips. With media, that could mean if I had more than one voice call, I would probably be either not hearing voice or even potentially hearing someone else's conversation. Probably not hearing any voice, any media. So I forgot that we needed to deal with that. Let's go ahead and take care of that real quick, and then we'll go back to testing our PSTN. So the command that we had already looked at earlier was network clock participate, but there was also another one. Do you remember what it was? Network clock select. So network clock select said choose a priority. First priority is the best. And then choose a controller, T1, and we're going to choose our voice controller, 000. And we're going to make that our network clock select. Now, the network clock participate was already there for WIC 0. So what's WIC 0? That's going to be the subslot 0 for the main motherboard, or slot 0. So we need to do show inventory to know where our port is. And we see that it's on subslot 0 on slot 0. So it's WIC 0. So the network clock participate was already there, but the network clock select, which one are we going to slave off of? That one was not there. So now that we've done that, actually let's go to our controller and say controller T1000, and let's shut it down. We can see that we shut down layer 3, and then we received a release indicator from layer 2, and the interface is now down. Now we'll no shut it. We also saw the network clock source transition from priority 1 because this was selected to priority 10. Once it comes back up, we see the D channel. First of all, the controller came up, then the D channel came up, and we should see the network clock transition back from priority 10 to priority 1. So now if we do a show controller, PST1 000, we're still going to see, we actually even see a line code violation and path code violations. That's because we just shut the controller down and brought it up. Okay, so what we're going to do right now is we're basically going to go back to testing our dial plan. And that's the reason I did it now instead of at the end, is so we can go back to testing it so that the current interval becomes a past interval. And we should see that the current interval should then, at some point in time, have 0 line code violations, 0 path code violations, and 0 slip seconds or errored seconds. Okay, so we'll let that go. So we're going to go back to testing our dial plan. And the next pattern to test is national. So we're going to go ahead and let's say we'll dial 91512-602-6222, which is line 2 here. And the call goes out, not with the 9, but just 1-512-602-6222. And that was based on what? That was based on forward digits 11. Finally, we'll dial 9011, 9011, 34, or sorry, not 34, 31, 34 is Spain, 31 for Netherlands, 20-703-7333. We're going to dial this number. Now, I've gone ahead and dialed. I don't know if you heard that go off hook, but it's waiting right now. You can see this display. It's waiting for interdigit timeout, that T, to take effect. Then once that happens, there it was. Now the call goes out. Remember, it's strip 9011 and we prefix 011 back. Now I could also, I'll do this call again, but as soon as I do it, I'm going to actually go down, and once it triggers the phone to call or dial, then I'm going to press the digit hash. And I'll actually go ahead and say debug VoIP dial peer, clear off my screen and scroll back so that we can see that occur. So I'll dial the number. Dial. Here the call comes in, and now I'm going to press hash. And once I pressed hash, it took a little while for the... let me do it again. This time I'll physically press hash instead of using the interface. So I'm going to dial the number. We see the debug behind it immediately come in. Now I press hash. And it automatically triggers that functionality. And I'm going to hang up. Okay, so it saw that hash come in and it went ahead and immediately sent the number. We see that the called number, if I look, the called number was 9011-3120-703-7333, and then all of a sudden the called number became that with a hash. Okay, so we actually saw that hash being pressed, or the router saw that hash being pressed. And note that we don't send the hash out to the PSTN. That is something that we don't need to worry about configuring support for the hash or stripping the hash, at least not in iOS. Now, when we get to UCM later in CIPT1, we'll see that we do have to configure support for the stripping of that hash. But in iOS, we do not have to. Very nice. Okay, we don't have to configure support for it being available to use or manipulation to strip it off at the end. So let's go ahead and just take this whole dial peer or dial plan. So each of these are dial peers, but together they form a dial plan. And let's copy it and let's go take it and put it into router 2. So show dial-peer voice sum. The only one I have is my skinny phone. I'm just going to hit config T because it's also in the US. Whoops. Anytime I highlight something on this particular client, which is called ZOC, Z-O-C, and the only reason I said that is because I get a lot of emails. Hey, what cool, or tweets, you know, what client are you using? It's called ZOC. It works for Windows and Mac. I happen to be on a Mac, and Secure CRT also works. Another one called iTerm also works. The last one is free. So anytime I highlight something, it automatically copies it. So I'm going to copy this from my text edit or notepad, and I'm just going to paste it in. We have a number of errors. What are those errors? They're related to the port. Why? Because we've not set up our port yet, at least not on router 2. So because router 2 is just like router 1, I'm actually going to do a show run. I'm going to copy the whole thing, and I'm going to do Command-Shift-E, which actually takes my entire configuration and takes and captures it into a notepad. And I'm just going to very quickly grab the pertinent commands. So network clock select and participate in reverse order. You know, I just hit network clock participate, and you know what happened? It told that particular WIC, WAN interface card, to participate in clocking. Now, the problem with that is that's also where my data interface is, and I currently am telnetted in through the data. And that's why I see that my OSPF process just went down and then came back up. So I've actually lost communication with that. And it's not going to let me in yet. Is it? There we go. It finally recovered from it. Okay. So network clock select. Another controller is already given the priority. Hopefully it's the right one. Do show run. Yeah, network clock select T1000. Okay, so that's fine. It dropped my data connection, but it's back up. Now I want to go down to my controller, and I'm going to say PRI group time slots 1 through 6. ISDN switch type must be set first. It certainly must. ISDN switch type primary. This is still NI. So then I'm going to paste that back in. PRI comes up. I'll be changing the PSTN to 6 channels in a moment. And then that automatically brought up my D channel, but I'm going to say ascending order so that we start at channel 1 for right now for outbound calls. Now for inbound calls, they were always coming at channel 1. The person that's transmitting the setup chooses the channel, at least chooses what they are going to try to negotiate. I'm going to need that voice translation rule, although the voice translation rule is going to have to be different. Why? Well, my extensions begin with 2, but my PSTN number isn't 206, it's 206.501, it's 512.602. So that's the rule for over here. I'm going to paste that profile in. Then I'm going to come down to my voice port and paste the translation profile. And now I can finally go back to my dial plan. So everything that I was just pasting in was everything that we just went through on router 1. So now I'm going to paste in my dial plan, and I don't have any problem with the port any longer because it's the proper port. So I'll write my router config, same as copy run start, and I will do a show dial-peer voice summary, and now I see my full dial plan implemented. So inbound and outbound should work. I'm not going to bother you with testing this right now. We will be testing it as we go along, but right now we're going to go ahead and move on to our router 3 branch 2 site. So we're going to use a similar dial plan. In fact, I'm going to go ahead and bring in the components from my that I was just copying and pasting. So let me just grab these. There will be a difference that you'll see in just a moment. And that difference will, of course, be that, where's my controller? Ah, there it is. Oh, I already pasted that. Okay. That difference will be that instead of a T1, I have, of course, at my international site, show inventory, and where is it? There it is, an E1. So it's just like my 2-port MFT T1, but it's an E1. Now remember, if this was a VIC2, I would have to issue the command card-type in order to tell what card in what slot or subslot, what type to be, either T1 or E1 for both ports. So I'm going to basically take everywhere that says T1, and I'm going to change it to E1. Replace all. There is :23. That's going to be replaced with 15. Okay, so anywhere where there is 000:23, that's going to be replaced with 000:15. That's because that was what would be created automatically when I do my PRI group. I'm not going to use 24 for the D channel, but that's what will automatically be created. So I'm going to replace all 7 of those instances. That included my not only my serial, my voice port here, but all of the places where my port is referenced in my dial plan. Okay? I'm going to take out this D channel of 24. I'm just going to use PRI time slots 1 through 6 because the iOS will automatically put in what is the D channel, which in the controller is going to be 16, everywhere else is going to be 15. We already talked about canonical versus non. And then I'm going to have to deal with my voice translation rule, which it's going to come in as 020. And we probably can just go ahead and do a call. Actually, once I paste everything but that into my configuration, okay, it's going to it's probably going to drop this connection again. Participate, WIC1, or sorry, WIC0. Yep, drop the connection. So up, there it is. It's back rather quickly. Okay, so it took both those, and once I put this command in, oh, it doesn't like cable link short. That's because it's an E1. It does take the PRI group, turns my B and D channel up, and I'm going to go ahead and say, now NI is not going to be the proper type, Net5 will. All of these are things that we inform you what the PSTN is doing. The PSTN carrier would of course have to inform you of these things in real life. And it tells me that I have to shut down my, did I have ISDN switch type? I must have already had it in there. Let's do show run pipe to include ISDN. It was already set globally to Net5. So that works, no problem. It was telling me that if I change it on the D channel, I have to shut that D channel down first. So that's fine. So now let's go ahead and do a call in, do show ISDN status. Multiple frames are established, so although I have 0 active layer 3 calls, layer 3 is up. So I should be able to go ahead and do a call in and do debug ISDN Q931. I should be able to see how calls are coming in. So let's go ahead and pull up one of the phones that is over there. Actually, we'll just use the PSTN phone for right now. So I will say, let's call in 020-703-7333. I'm sorry, 3001. Now, it may not go anywhere, but what I wanted to do is see how the called party comes in. And the called party does come in with 020. Okay, so now I'm going to take that and I'm going to use that for my voice translation rule. So 020, 703, and then the 3001 or 3 dot 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 is what I want to use here. 3 dot dot dot. Okay, so 020, 703, 3 dot dot dot, and \1 to append that first set. Okay. I'm using Notepad to speed things up a little bit since while you want to see this, I'm sure, you probably don't necessarily want to just have me type the same thing in over and over again. So now I'm going to apply this to the voice port. And then I'm going to use at least my inbound dial peer to be the same. Now my outbound dial peers might be different. And in this case, they are. My destination pattern is 112 for emergency services. And my secondary dial tone for everything is going to be 0. So I'm going to put 0 here and then 112. Here it's going to be at least 0, 0, and 0 for my local, national, and local, national, and international. But my national is not going to be dialed like this. In this particular case, I could do national as 7 digits or as the full national code. So in this particular city and this particular dial plan, and certainly some countries allow this, I'm just going to dial 0 for secondary dial tone, then 0 for the national code, and then the particular rest of the digits. So it could be 20 or it could be 10, depending on the city code, and so on. The only thing it could not be is another 0. So I'm going to say that the first digit could only be 1 through, let's say, 9. Okay, so that's the city code is 1 through 9 dot, and then 7 digits. 1, 2, 3, 4, 5, 6, 7. So a total of 1, 2, 3, 4, 5, 6, 7, 8, 9, and then 10, including that national access code of 0. And we don't forward the PSTN digit of 0 or PSTN access code of 0. So we want to forward 10 digits. Okay, international is dialed not by 0011, but 0 for secondary dial tone, and then 00. And so we want to prefix 00 out to the PSTN. That's our particular dial plan for this site. Again, if you're renting our labs, we provide all that information for you in the Rack Rental Access Guide. So I'm going to copy all of this, and I'm just going to paste it in the router. And then we'll go ahead and test our dial plan. Okay? So let's pull up one of those phones. Let's just grab .24. Whoops. And so I've got extension 3001. And we will begin. Let's clear off our screen and scroll back. And I'm going to begin by dialing in from the PSTN again, now that I have that voice translation rule set up. And we can hear the call ringing. And we can see the call coming in from 1-206-501-5111. So inbound calls now work. So what about outbound calls? Let's try 112. Okay, there goes the call out to 112 to the PSTN. Oops. problem was that I didn't have my handset on the cradle, even though it shows it there. So whenever I hit speakerphone, it was simply going to handset. Okay, so we did 112. Let's clear off our screen and scroll back and go back and do 0112. And we still forwarded 3 digits, so 112. By the way, the screen shows the call after the digits have been manipulated, you'll notice. Okay, so it would have shown 011 to begin with, but then it updates the screen to show the manipulated digits, which is typically what we want, not always. And we'll look at ways to get rid of that behavior in UCM later. But for now, in CME, this is the default behavior. So let's now dial 0 for outside dial tone, and then 020 703 7333, which is a PSTN number. Remember, we don't want to see this first 0. We do want to see the second 0 and the remainder of the digits. Okay, so here the call goes out. We see 020 703 7333. Now the calling number is only 3001. And there are things that we can do. Voice translation rule certainly comes to mind first as ways that we could change our outbound calling number. So on the inbound, we change called. On the outbound, we may need to change calling. Okay, so that works for a local. What about a national number? So 0010. Let's see what my PSTN phone is. 704 7444. So now the call should be going out as a national call and ringing in on this 4th line. And once the screen for the PSTN phone updates, there we go. We see the call coming in on that 4th line. So the national call worked, chose the same dial peer. And then finally, I've hung up, and now I'm going to change the call to 0001. So international call 206 501 5111. Actually, instead of calling out to the PSTN phone, let's call all the way over to our branch 1 router. I'm sorry, our corporate headquarter router. Let's just clear off the screen and scroll back of all of these. And let's call in to the first phone over there. And I'm just going to go ahead and pull that screen up. There we go. I've got that one up as well. So I'm clearing the PSTN screen. I'm going to grab. So this is over at the second octet indicates router 3, branch 2. And on this phone, this second octet .1 indicates router 1 or corporate headquarters. Let's change these to every 2-second auto screen refresh. And let's call 000, so 0 for outside dial tone, 00 for international, 1206 501, but let's call 1001. We're on the corporate headquarter router over here. Let's go ahead and press the hash. So we should see the call coming in. It left router 3. It's coming into router 1. And it is certainly ringing there, we see. And I've gone ahead and cleared the call off. So our international calls work, and we can call from site to site, but at this point, only over the PSTN.